Electrochemical cells, also called galvanic cells. This is the topic of this video. Use the metal reactivity series to predict which electrode will be the anode and which will be the cathode when the following half cells are connected. Write half equations for the reactions occurring at each electrode. And we have 3 questions. We need to answer them. Before answering them, we need to see the reactivity order of metals. So the highest is potassium, which is the most reactive metal, and it can be oxidized very easy. So it's strong reducing agent. However, gold is the weakest one, so it cannot be oxidized, and it's not as good reducing agent, opposite to potassium. Remember, in electrochemical cells or galvanic cells, red K means reduction at cathode, and anox means oxidation at anode. It's easy to remember where oxidation happened and where reduction happened, red cat and anox. So the answer of first one, zinc is a more reactive metal than iron, so is oxidized. Zinc is oxidized. So zinc will be at anode, as we said before, oxidation at anode. So zinc will be oxidized into zinc ion at the anode, and iron would be reduced to iron ion at the cathode. And this is the 2 half equations. Zinc will lose 2 electrons, means oxidation, and iron will gain 2 electrons, means reduction. Magnesium is more reactive metal than iron, so magnesium will be oxidized and lost electrons, 2 electrons, and ion will be reduced to give iron metal, and this is reduction happen at the cathode. Again, magnesium is more reactive than copper, so magnesium will be oxidized at the anode, and copper will be reduced at the cathode. Here, another question. Draw a voltaic cell, so we can call it voltaic cell, galvanic cell, electrochemical cell. All of them are correct. Draw a voltaic cell with 1 half cell consisting of magnesium and a solution of magnesium ion, and the other consisting of zinc and solution of zinc ions. Label the electrodes with name and charge, the direction of electron and ion movement, and write equations for the reactions occurring at each electrode. Then draw a cell diagram to represent the above voltaic cell. The answer: magnesium is a more reactive metal than zinc, so magnesium will be at the anode where oxidation happens. Don't forget anox, oxidation at anode. While we'll put zinc, which is less reactive than magnesium, at the cathode, and zinc ion will be reduced to zinc metal and precipitate at the cathode or this electrode. Cathode in the voltaic cell is a positive electrode, while the anode is a negative electrode. Here is a solution of magnesium nitrate, and here zinc nitrate. And in the salt bridge, so the anions will move this direction, and the cations will move this direction toward the half cell of the cathode. And cations will move this direction to compensate zinc ion, which will be reduced and precipitate on the cathode electrode. While here the nitrate or the anions will migrate in the salt bridge to the anode half cell, this direction. Okay, and this to compensate the nitrate ion which react with magnesium in this solution. Then the answer of the second of the rest of the question, magnesium metal will be oxidized to magnesium ion, and zinc ion will be reduced to zinc metal. Last question. Predict what would happen if an iron spatula was left in a solution of copper sulfate overnight. First, establish from the reactivity series that iron is a more reactive metal than copper, and so will reduce copper ions in solution. We know more reactive has a higher power to reduce the other metal, less reactive metal. So iron will be oxidized and form iron ions. And the observations depend on knowledge that you need to know that copper ions are blue color, or copper solution is blue, while copper metal is red brown. So what the equation? Iron spatula, when left in copper sulfate solution, which is blue, iron will be oxidized to iron ion, while copper ion will be reduced to copper metal, which is red brown. So the blue color will disappear, and the red brown it will form, which is precipitated copper metal. Also, iron spatula start to dissolve in the solution of copper sulfate overnight. So here's the answer. The iron spatula would slowly dissolve as it is oxidized to iron ions, and copper metal, red brown, would precipitate as copper ions are reduced. The blue color of the solution would fade as copper ions are removed.